Hello, Year 5s. How are we doing? Well, I hope. Welcome to another Problem of the Week with me, your host, Mr. Morrissey. Now, what have we been looking at in some of our recent learning? Well, it's all been about those lovely things, decimals. We've got stuck into those beauties. And last week, we even added them. Can you believe added decimals with an equal number of decimal places? Crazy stuff. And today we're going to, you'll never guess it, subtract decimals with the same number of decimal places. So looking at the inverse, flipping it on its head. How exciting! Let's begin. So to recap quickly, we looked at adding decimals like this, 3.45 plus 4.16. This is how it might look in a place value chart. So we start with the hundredths, of course, but because we have 11 and we know that 10 hundredths is the same as 1/10, you can just swap 10 of these for one of these. And then we can just read off, we've got 100th here, there are 6/10ths there, and we have 7 ones, and of course over here in the column addition method, 5 hundredths plus 6 hundredths is 11 hundredths. So we need to regroup. Put 1/10 there, 1/100th there. Same number, written in a different way, regrouping, and then adding up our tenths, so that's 6/10ths, decimal point, and 7 ones, 7.61. So an example there with regrouping. But if you remember, I also talked about efficient methods and that you can make up your own methods that can be easier to do, quicker to do, and more likely to get you the correct answer than the standard method sometimes. So you should always be asking yourself, what's the best method, the most efficient method for this question? How did this method work? We had 4.99 plus 3.67. By using our rounding skills, we can make much nicer, rounder numbers to add easily. So adding 1/100th to 4.99 gets me 5.00. Adding 3/100ths to 3.67 gets me 3.70. I can add those easily, 8.70, but I must take away the extra 400ths. I added on 400ths altogether, didn't I? So I must take those off. The final answer is 8.66. So as I said, we're looking at subtracting today, and the numbers will always have the same number of decimal places. In this example, we're using the place value chart to work out 3.45 minus 1.62. So how could you work that out, but with the place value chart? Looking at the hundredths first, I've got 5 hundredths, take away 2 hundredths. I'm going to take away 2 of these, leaving me with just 3 hundredths. Going over to the tenths, it's 4/10ths, take away 6/10ths. So obviously I'm going to cross out 6 of these tenths, amn't I? Or can you see a problem with that? Well, there are not 6/10ths for me to cross out. There's only 4. But we know it's not a problem, because inside these ones, there's loads of tenths. We know that 1/1 is the same as how many tenths? 10/10ths. We know that, don't we? 10/10ths is 1 whole. So we have plenty tenths to be able to take away 6. We just need to do an exchange. So I'm going to exchange this one for 10/10ths. Now by doing this, have I changed the value of the number? I have not. Because I've exchanged two things of equal value, 1/1 for 10/10ths, the overall value of the number is exactly the same. It's still 3.45. And now I can take away those 6/10ths, can't I? Leaving me with 2, 4, 6, 8. And looking at the ones, it's 3 ones take away 1 1. I've actually only got 2 ones there, but I'm taking away one of those ones, cross one out, and I'm left with 1. So the answer is 1.83. If I was doing just the standard written method, I would start with the hundredths. 5 hundredths take away 2 hundredths is equal to 3 hundredths. I would go over to the tenths next, of course. 4 tenths take away 6 tenths. Well, as we've already seen, there's a problem there. I need reinforcements. I need some more tenths. I'm going to take away 1, exchange it for 10 tenths. Adding it on to the 4 tenths gives me 14 tenths. That's why I write it like this. I've got 14 tenths now. So 14 tenths take away 6 tenths is equal to 8 tenths, and then 2 take away 1 is 1. So again, 1.83 is the answer. Another example, but no place value chart or other representation to help us. Let's just work through it like this. So 3 take away 8, that's 5, of course. 4 take away 3 is 1. 5 take away 2 is 3. So the answer is 3.15. Happy with that? What, you're not? You think I made a mistake? That's very rude, but also very correct. I did make a mistake, a deliberate error before you rush to judgment. And I deliberately made a very common error when it comes to column subtraction. So, can you see the error I made? Where did it all go wrong? Often we forget that it has to be top digit take away bottom digit and not the other way around. So when we see a 3 and an 8 and a minus sign, we just think, oh, 8 take away 3 is 5 because we're more used to that and more confident with that maybe. But that's not what we're being asked to do. Think about what this means. 5.43, from that number, from that whole, we're taking away 2.38. But we take it away in parts. We partition 2.38. We take away 8 hundredths from 5.43. We take away 3 tenths, and then we take away 2. But we're taking away 8 hundredths from 5.43. We're not taking away 3 hundredths from 2.38. So let's rewind and let's try again. 3 hundredths take away 8 hundredths. Well, if you imagine that in your head, there's 3 cupcakes on a plate. Can you take away 8 of those 3 cakes? No, you cannot. So we need to do an exchange. There's loads of hundredths in our tenths, so we'll take one of those tenths away, leaving us with 3 tenths. But we exchange that 1 tenth for 10 hundredths and add those 10 hundredths onto our 3 hundredths, giving us 13 hundredths. Now we can do 13 hundredths, take away 8 hundredths, that's 5 hundredths, over to the tenths. 3 tenths take away 3 tenths is no tenths at all, and 5 take away 2 is 3, so 3.05 was the correct answer. Well done if you spotted my deliberate mistake. We're going to look at one more problem, and again we're going to think about efficient methods. I've got a pretty cool method, I think it's cool anyway, that I want to share with you. See what you think. Maybe you'll think it's cool, maybe you won't. So let's see. Here's our problem. You buy the book Chocolate Desserts by Ivor Sweettooth. It costs £6.75. Good value, by the way. If you pay with a £10 note, how much change will you get? So by all means, reread the question. I think it's a good idea to read problems more than once, identify the key information, and think about how you would work it out. What's the operation? What's the calculation here? 2 brilliant but very simple questions you can ask about any problem to help you decide how to work it out are these 2. First of all, do you know the whole? Are you given the whole, the total in the question? And is it equal parts? Are we working with equal parts? Is every group, every part the same size? So let's go through them. Do we know the whole? Are we given the biggest value of money? Yes. It's £10. £10 is the whole. That's the biggest amount of money, isn't that right? Now, are we working with equal parts here? Do we have lots of parts and they're all the same size? No. There's one book for one course. There's one £10 note. I'm not seeing equal parts there, are you? That's a no. So what's our operation here? We've got the whole. We've got the biggest amount, and it's made up of unequal parts. We're looking at subtraction. We have a whole, we can take away one part to find the other part, subtraction. So when you know the whole and it's not equal parts, you're thinking of subtraction. So what's the calculation? It's £10 minus £6.75. That's going to give us our change. Now this is a decimals question, isn't it? Can you see the decimals? Well, I'm going to use column subtraction with the decimals so you can see them. Now I'm going to do something pretty cool here. This is actually a very tricky, quite complicated, quite messy question to work out using column subtraction. So I'm going to do something cool here to make it super, super simple. I'm going to take 1 penny off both amounts. So what's 1p less than £10? It's £9.99. What's 1p less than £6.75? It's £6.74. Now, do you see that if I take 1p off both amounts, the difference between the two numbers, the gap, will be the same? So £10 take away £6.75 is exactly the same as £9.99 take away £6.74, and that's much, much easier to do. Why is it much easier to do? Well, let's go through it and see if you can spot what's so easy about this. So hundredths, 9 take away 4 is 5. Tenths, 9 take away 7 is 2. Ones, 9 take away 6 is 3. And that is our answer. We can put it in here. No adjusting required. We reduced both by the same amount. The gap, the difference between the numbers is the same. So £10 minus £6.75 is £3.25. Why was this version so much easier? There was no exchanging. You can see that there'll be no exchanging. All of these digits are lower in value than all of these. No exchanging. So we can use an equal difference method to make subtraction easier. So keep an eye out for when that might be a good method to use. It's particularly good when the whole has a lot of zeros, because that means lots of exchanging. Over to you for the independent tasks. So applying your understanding of the methods we've looked at, and then being careful when it comes to exchanging. 2 further questions. The first one is tricky enough. The bar models there will help you, so I would use those or another effective method. And then we have a puzzle, a number pyramid. Can you find out what goes in those gaps? Time for some answers. Here are some of my answers. I hope you got the same responses. If you didn't, it means that one of us went wrong. So why don't you check your work to make sure it wasn't you? And then our answers to the final 2 challenges. Sadly, it's time to say goodbye as another problem of the week has tragically come to an end. But don't fret, we will meet again soon, I promise. And in the meantime, take care of yourself. Bye!